Hey, welcome back to chemistry. And so what I'm going to be talking about now is determining something called the percent composition by mass of each element in a compound. This is covered in section 3.9 in your book. So there's really a very specific formula to use, and it's right here. So your goal is to look at a compound and identify the elements in it, and then for each element, what is the percentage of that element by mass in the compound? And so there's a formula that you will use for that. And so it is that the percentage composition of the element is going to be equal to the number of atoms of that particular element times the molar mass of that element divided by the molar mass of the compound, and then times 100%. And so that should give you an answer in percentage. Okay, so I think the best way to handle understanding how to do this is by doing some problems. So let's look at the first problem. So the first problem is determine the mass percentage of carbon and hydrogen in that molecule there, which is C4H10. And then I give you a molar mass for that. So this is how you would end up doing this problem. So you have C4H10. So I'll write this here. And what you have to do is figure out the percentage of carbon by mass in this molecule and the percentage of hydrogen by mass in this molecule. So this is how I would do it. So it looks like the formula is indicating that there are 4 carbon atoms in one molecule. So it's going to be 4 times the molar mass, I'll just write mm for molar mass, of carbon divided by the molar mass of C4H10 times 100. And so what would it be for hydrogen? Well, for hydrogen, it looks like we have 10 hydrogen atoms in one molecule. And so we would want 10 times the molar mass of hydrogen over the molar mass of the molecule times 100. Okay, so let's kind of fill in some numbers here and see how that goes. So it's going to be, for percentage carbon by mass, it's going to be 4 times the molar mass of elemental carbon. You can just look up the average atomic mass of carbon in the periodic table, and that would be the elemental mass for carbon. And so it's going to be 12.01. I'm going to write grams per mole, because that's the molar mass for carbon in those units. C4H10, it looks like we were given that, so it's 58.12 grams per mole. And then don't forget to multiply by 100. Okay, so let's do the formula for hydrogen. So it's going to be 10 times the molar mass of hydrogen. As I recall, that's 1.008 grams per mole over the molar mass for C4H10, which is 58.12 grams per mole, times 100. Now, when you do the math, there's something to notice with both of these formulas here. So with the percent carbon by mass, you see there's grams per mole in the numerator and there's grams per mole in the denominator. So these would cancel out. And so all you're left with should be some kind of number, which I'll work out in a minute. So here for percent hydrogen by mass, same thing. Grams per mole in the numerator cancels out grams per mole in the denominator here. And so when you do the math, you should be just left with a number. And it'll be, I guess the units here, I should have indicated, should be percent. So let's go ahead and do that. So it's going to be 4, get my glasses on. Let's see. 4 times 12.01 divided by 58.12 times 100. And so I get, for the percentage of carbon by mass, the number I get for carbon, maybe I'll write this down here. Carbon is going to be 82, and it looks like what we have, we're going to deal with 4 significant figures, so let me write that in 4 significant figures, 82.66%. Now how about hydrogen? So hydrogen is 10 times 1.008 divided by 58.12 times 100, and I get 17.34%. Now, in this compound, C4H10, carbon and hydrogen are the only elements, and so in theory, these percentages should add up to 100, so I'm just going to check that by adding into the carbon percentage to the hydrogen. Yes, I get 100.00%. So apparently I've done the problem correctly. So let's move on to another one. So problem 6 reads, what is the percentage of mass that belongs to hydrogen in water? And the molecular mass of water is 18.02. Okay, so what is the percentage of mass that belongs to hydrogen in water? So what we want is percentage of hydrogen by mass. And the molecule this time is water, H2O. And so what we want to do is, to do that, we take 2 atoms of hydrogen times the molar mass of hydrogen over the molar mass of water. So it doesn't look like it's going to be too difficult to do, right? And then of course we multiply by 100%. And so it's going to be 2 times the molar mass of hydrogen, which is 1.008 grams per mole, over the molar mass of water, which is 18.02 grams per mole. And we would multiply this by 100%. So let's see what we get here. So it'll be 2 times 1.008 divided by 18.02 times 100. And let's see, how many significant figures we have to deal with? It looks like, again, we're going to be having an answer in 4 significant figures. So it looks like it's the percent hydrogen by mass in water should be 11.19%. Okay, so what I'm going to do is I'm going to figure out the percent mass by oxygen, because I think we're going to need that in the next problem. So it's percent mass of oxygen. And so how would you do that? Well, there are only 2 elements in this compound, right? Water. So basically, whatever mass doesn't belong to hydrogen will belong to oxygen. So it's going to be 100 minus 11.19% should be the percent mass by oxygen. So it's be 100 minus 11.19, and I get 88.81% oxygen in water. Okay, now let's do the next problem since we have that information. It says 7, if you have 60 grams of oxygen in a sample of water, how many grams of hydrogen would you have? Okay, so this is a really good problem. So we have now 60.0 grams of oxygen. And again, this is just oxygen atoms in a sample of water. How many grams of hydrogen would you have in this sample of water? Okay, so what we want is we want an answer here in grams of hydrogen for this sample of water. So somehow we have to convert grams of oxygen to something different, grams of hydrogen. So the question is, do we know some kind of proportionality between oxygen and hydrogen? Now be careful. You have to be careful about what proportionality you use. So for example, we know, for example, that when we have 1 mole of water, we have 1 mole of oxygen atoms and 2 mole of hydrogen atoms. But here we don't want to really look at moles. I mean, we could do that. We could convert we can convert grams oxygen to moles oxygen, and moles oxygen to moles hydrogen, and moles hydrogen to grams hydrogen. That is possible, but there's actually a little bit easier way to do that. So when you're looking at these percentages, realize that these numbers also equate with grams. So if you have a water, which is 11.19% by mass hydrogen and 88.81% by mass oxygen, What that means is if you have 11.19 grams of hydrogen, you have 88.81 grams of oxygen. So that is a proportionality you can use. So I can sort of use this for this problem here. I'll write this down here. 11.19 grams of hydrogen is equal to 88.81 grams of oxygen. So this could be used in this problem. And so you can write out fractions like this. Okay, so the goal is to choose a fraction so that the grams of oxygen cancels out, leaving an answer in grams hydrogen. So which one do you want to use? It looks like I'm going to use the first one. So times 11.19 grams of hydrogen over 88.81 grams of oxygen. So the math should be 60 times 11.1 divided by 88.81. So let's see what I get. So 60, 11.19. Okay, so I get a large number on my calculator, but it looks like I'm going to round this into 3 significant figures. So it looks like if you do the math, I get 7.56 grams of hydrogen. Okay, thank you for listening to that. We'll see you next time.